First, the video is starting off with a preview in order to catch your attention.
Create a plane in Blender and add 2 loop cuts. Notice that in Blender it says there are 8 vertices. We select this plane and export it, calling it plane1.fbx. We look at the plane in Unity and confirm that yes, there are 8 vertices. Back in Blender, we select the middle vertices and raise them up. Notice that Blender still says there are 8 vertices. We export this, calling it plane 2. Looking at plane 2 inside of Unity, we see it says there are there's 12 vertices. What's going on? Back in Blender, we don't edit any of the vertices, we just right-click on the object and select Shade Smooth. We export this, calling it plane 3. We look at plane 3 inside of Unity and see that once again we have 8 vertices. Back in Blender, let's start over, delete the object, create a new plane, adding 2 loop cuts. This is what we started with, which we confirmed has 8 verts both in Blender and in Unity. This time we're not even going to touch any of the vertices, we're only going to edit the UVs. Mark the edges of the rightmost rectangle as seams, UV unwrap, and move some of the UVs around. We export this, calling it plane 4. Take a look at plane 4 inside of Unity, and we have 10 vertices. Why 10? Quick recap. Flat plane, 8 vertices. Bent plane, 12 vertices. Bent plane, but with smooth shading, 8 vertices again. Flat plane, but with different UVs, 10 vertices. Do you have no idea what's going on? Well, this is exactly the video for you.
Okay, we finished the preview. Now it's time to roll the intro. I want to do a little bit of shameless self-promotion and tell you about my game.
Cannon Fodder is my VR destruction game. You launch yourself out of cannons, you go flying through the air. It's super fun, it feels great. You can buy it for Quest, on the Oculus Store, on the Steam VR Store. Links in the description.
Finally, start the video.
Alright, enough wasting time. Let's get on with the video. Here is the main menu scene for my game, Cannon Fodder. I don't know if the main menu is going to look like this when the game releases, but this is what it looks like right now. And here is the level selection screen. Because this is a VR game, you want everything to be physical, actual objects you can kind of touch and interact with. So I've got post-it notes on a board here. The post-it notes can have, well, we've got the numbers, right? So this will be the number of the level. We have stars indicating how well you did on the level, and then we've got the color of the post-it note, and that can be different colors indicating if the level's locked or things like this. So I'll hit play and you can get an idea, right? They're all different colors. We look at number 10 and we've got this script here, post-it UVs. We've got the number is set to 10, stars is set to 2, color is set to gold. And that's exactly what we have, right? We've got this tack, we can delete that. So it's really one game object. And this one game object has one mesh called post-it. There's one material called post-it matte. The material has one shader called post-it shader. There's one texture input, which is these numbers with a transparent background. So again, we have one game object, one mesh, one shader, one material, one texture. And yet, because we're using this script here that I'm going to teach you how to make in this video, we are able to have, well, there's numbers between 0 and 99, so 100 numbers, 4 different star variations, 4 different color variations, so 100 times 4 times 4, 1,600 variations of post-it notes, right? 1,600 variations with only one of each thing, right? One material, one texture. We can create all these different variations. I would say this isn't a tutorial, this is a lesson. It's teaching you about what vertices are, how they work, why Blender does certain things, why Unity does certain things. The actual code to create something like this is trivial. So, you know, don't feel the need to follow along and do the exact steps, you know, it's gonna be all over the place. The idea is to just kind of understand the concept. So just watch the video. First topic, real quick, what is a vertex? You're thinking a vertex is a position in 3D space. We got, you know, that's a vertex, that's a vertex, that's a vertex. We go over to Blender, I got this triangle here, and it says this one is at position 0, 0, 0. This one is forward on the Y, so Y is 1, this one's forward on the X, so X is 1. So a vertex is a position in 3D space. Edge is the connection between two vertexes. Face is, if it's a triangle, then it's 3 vertices put together. Vertex fundamentally position in 3D space, right? Wrong. Totally wrong. Go over to Unity here. I've added this army truck. This has got 17,000 something vertices. Nice looking truck model. This has different properties, okay? It has position, normal, tangent, UV. UV is texture coordinate. A vertice is a container that contains different values. So it contains a vector 3 for the position. So you have X, Y, and Z for the position. It has a vector 2 for the texture coordinates because a UV position is only X and Y. And then it's also got vector 3 for normal, vector 4 for tangent. We can do other things. You can have vector colors. If we go into Blender here and do, we just had it, vertex paint. I can do like painting on here. I don't know that this is going to be visible. I do export FBX, and we'll call this one, you know, whatever, 1, 2, 3. We'll delete it in a second. Back into Unity, and I take a look at this, and we can see, there you go. This is 3 vertices, and it has a color value as well. This is what a vertex is. It's a container that holds different types of properties. One of them is position. Let's make some procedural meshes using code. Here in my scene, I've got a game object called draw stuff, and it has a script called draw stuff. The mesh filter is empty, there's nothing there. The mesh renderer just has some default gray material on it. Right now there's no mesh. Go to this draw stuff component here. In the start function, we're going to create a new mesh. We're going to call it procedural mesh. Then we're going to assign it 3 vertices. So this is an array of vector 3 objects. We're setting, you know, X, Y, Z is going to be 0 for all of them, so we don't even put it in. The first vector is going to be at 0, 0. Then the next one's going to be 0, 1. X will be 0, Y will be 1. We assign these vertices, and if we just left it at this, nothing would show up. We need to create triangles, and a triangle is a set of 3 indices, you know, linking to 3 vertices. So for this triangle, we say the first vertex of this triangle is vertex 0, which is this one here. And the second one is vertex 1, which is this one here. So let's go back to Unity and hit play. We see our triangle, and if you remember, this one was the first one, this is the second, this is the third, or, you know, 0, 1, 2. We can just, you know, 0, 1, 2. And the position of this one is 0, 0, the position of this one is 0, 1, and the position of this one is 1, 0. And we defined it as starting here and going this way around. So, you know, going around in a circle like this. We say this is the first one, this is the second one, this is the third one. We're going around in a clockwise direction. Instead of doing 0, 1, 2, what if we did 1, 2, 0? And when we run it, we get the exact same result. Now, what I want to show you is, what if we do it in the other direction, okay? We start at the bottom. Let's say we start at 0 again. But this time, we then go to vertex number 2, and then vertex number 1. We hit play, and you don't see anything. We go, okay. So, you know, this time what we're meant to be doing is we're meant to be going, you know, 0, 2, 1. We're going in this order, counterclockwise. And nothing shows up. Well, actually, it is there. You're just looking at the back of it. Okay. Whether or not you are looking at the front or back is determined by the order that the vertices appear in. So if it's going clockwise, then you're looking at the, you know, the front of the clock, right? So this here is, we know this is 0, this is 2, this is 1. So, you know, in this way, on this side, this is going clockwise. We were just looking at it from the other side. So we were having, you know, it was 0, 2, 1, and this was anti-clockwise. So that means it was the back. We want to look at it from this direction. So we're going to set this back to be 0, 1, 2. I hope that makes sense. Now let's draw a second triangle, and I want it to start here and go from here to here to here and back. So this is at 0, 1. So I'm going to put this at 0, 1.1. This will be 1.1, 1.1, and then this will be 1.10. Okay. So back over to our code editor, and let's add 3 new vertices. And this one we will start at, we said X will be 0, Y will be 1.1. The next coordinate 1.1 by 1.1, and then the bottom one, X, will be 1.1. And then we will define another triangle here. I'll just put this on a new row, and this will be vectors 3, not vectors, vertices 3, 4, and 5. Hit save, come over here and run it. And presto, we have 2 triangles exactly as you would expect, okay? Now let's make a little modification. Let's push these 2 triangles together. We come over here. This one will be at exactly 0, 1. This one will be at 1, 1, and this one will be at 1, 0. And here we have our 2 triangles pushed together. I have shaded wireframe on. If we just did shaded, it would just look like this. I have shaded wireframe, so we can see we've got our 2 triangles. And one thing we can also do is if we click on this and go to the mesh filter, we have our mesh there called procedural mesh. If we look at this, we can inspect it and see we have 6 vertices which are holding position values. We haven't set normals or UVs or colors or anything else. So right now it is just position values. So this is what we currently have. We have 2 triangles, 6 indices, 6 vertices. And the triangles are real. We can see them in Unity. We come over here, we go, you know, this is triangle 0, this is triangle 1. We look in the code, and the triangle, I mean, it's just a list of 6 numbers. okay? And these 6 numbers are just pointing at corresponding 6 vertices. To say that triangles exist, I mean, what we do is we define an array here of indices, and that's all we define. We don't define the triangles anywhere. I mean, in Unity, they call it, the dot triangle property. You don't set the indices, you set the triangles, but the triangles themselves are just an emergent phenomenon, okay? So we go the first 3 indices, that's triangle 0, the second ones are triangle 1. We don't have to, declare these values anymore. If we add 3 more indices, that automatically means we've added a new triangle. These indices are all in order, 0, 1, 2, 3, 4, 5. So they are pointing in order 0, 1, 2, 3, 4, 5 down here. So these are all pointing directly across at the corresponding vertice. Now, for these vertices, we have 6 of them, and all of them only have a position value. At indice 3, we're currently pointing over at a vertex which has position with x equals 0, y equals 1. But we already have that up here. These 2 lines are identical in every single way. So we don't need to push index 3 directly across. We can point it at the vertex in position 1 and delete this. Here, this is a new position, which is 1, 1. But for index 5, this is x equals 1, y equals 0. That one already exists up here. So we can point index 5 at vertex 2 and delete this one. So let's look at this in code. What we want to do is look at vertex 0, 1, 2, 3. So we delete vertex 3. And in our indice list, instead of pointing at 3, we point at 1. 4 is at a new position, and then 5, we can delete 5, and we instead point 5 at 2. Because we've changed the order of the list, this last one here is no longer actually 4, this is 0, 1, 2, 3. So I'll change the 4 to a 3. Looking at it in Unity, it looks exactly the same as it did before, but if we click on this and inspect our procedural mesh, we'll see there are now 4 vertices. We used to have 6. Now if we look at the indices, there are still 6 indices. We can see there's 2 triangles with 6 indices and 4 vertices. And that's exactly what we defined here. We have 2 triangles, 6 indices, but only 4 vertices. Here I have a plane which is 1 by 1. But if we look at the wireframe, here you can see it is cut in the middle and also triangulated. It's not quads, because in Unity, in gaming, we're always working with triangles, okay? The position of this vertex here is 0, 0, 0. This one is 1, 1. So this one in the middle is x is 0.5, y is 1. And we see there's 6 vertices here. You can, if I move over, there you go. On the bottom here, you can see it says 6 vertices. Okay, let's look at this from above, and we will assign some triangles to this. So I will say that this is triangle 0, this is triangle 1, this is triangle 2, this is triangle 3. And we're going to assign points. So, points here, here, and here. Every triangle has 3 points. So, triangle 0 has a point at position 0, 0, which is this one. Then it's got 0, 0. Then the next point is here, which will be 0, 1. And the next point is here, which will be x will be 0.5 and y will be 1. Triangle 2, for example, this will start off down here, which is 0.5 comma 0. And then the next one will be up here, which is x is 0.5, y is 1. And then this one over here, 1, 1. If we're only looking at these 2 triangles, this one and this one, we would have 6 indices between these 2 triangles, and we look for duplicates and we go, okay, this has these 3 vertices, this has, well, we can cross that one out. This has these 3 vertices. Okay, and I've drawn this out in Photoshop, so triangle 0 corresponds to a position, 0, 0, 0, 1, 0.5, 1, right? And we do all the triangles like this, and so we have 12 indices, but we can cancel out some of these, and so now, because of these duplicates, we only have 1, 2, 3, 4, 5, 6 vertices, which is exactly what we're seeing in Blender. Now I want to add a new factor in. Let's look at the plane from the side, and I'm going to turn on vertex normals. So we can now see the normal direction of these vertices, and they're all pointing up. Okay, so now we factor this in to the vertex value. The first index will be position 0, 0, which is here, and the normal is pointing up. So the normal is pointing up. And does this change anything? Not really. I mean, here's triangle 1. Triangle 1 is also having its first index, in this case index 3, point to 0, 0, normal up. These 2 are still identical. which means we can still cancel them out once we factor in the normals, and we still end up with only 6 vertices. I'm going to turn off the viewing the normals here so I don't ruin the surprise. I'm going to grab these middle vertices and I'm going to move them up a little bit. Now let's take a look at the normals. Ooh, look at this. This one here at 0.00, it's pointing off to the left. This vertice, this single vertice, has normals in 2 directions. Let's map this out on Photoshop. Here's what everything looks like if every index points to a unique vertex, which we could do, but we don't want to do. We want to be more efficient than that. And there are still some here which are identical that we can cross out. For example, the first vertex here, position x equals 0, y equals 0, normal off to the left. And on this one for triangle 1, we have position x equals 0, y equals 0, normal off to the left. That's this one over here. These 2 lines, you can look at them, they are identical. Cross out some stuff that is identical, because if something's identical, you know, why create a new vertex? Why not just reuse an existing vertex? We look at triangle 2. Let's take a look at this bottom point here. Position x equals 0.5, y equals 0, normal off to the right. On the line directly above this, we have position x equals 0.5, y equals 0, normal off to the left. These are different vertices. Blender is lying to you when it tells you that this is one single vertice. It is actually 2 different vertices. The values are different. The position value is the same. The normal value is different, which means if we take the single object as a whole, these are 2 different objects with 2 different values. They are 2 different vertices. Count these vertices up and we have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to export this into Unity and drag it into our scene. If we look at the mesh details, there are 8 vertices. There are 12 indices, so 4 triangles. Assuming you're using triangles, you can use quads and other things in Unity, but don't. The indices are always going to be 3 times what the triangles are. Or I guess technically you define the indices. So the triangles will always be 1/3 of what the indices are. But there are 8 vertices here, and we just explained why. It's day 2. Enjoying my coffee. I have this tent structure. This is the same thing we had before. We can look at it. We have, you know, the 2 different vertices at the top with normals in different directions. I just put it in this beautiful purple scene here with a light, and we're using cycles rendering. Here's what I'm going to do. I'm going to right click and do shade smooth. And we can see it can be difficult with the YouTube compression sometimes, but I mean, I think you can really tell it's smoothly transitioning over here. Shade flat, hard edge, shade smooth, looks like this. Let's take a look at the normals now, and what do we see? At the top, we now just have a single vertex with a single normal. It used to be one off to the side like this, one off to the side like this. Those have been averaged into just a single position here. This is how smooth shading works. So if we look at it from the side, what it's doing is when it's flat shaded, the normals here and here are the same, and so everything is rendered as if the light is hitting it from this angle. Here, because the vertex at the top has a different normal from the vertex at the bottom, as it renders across here, it's making a interpolation between these 2 normals. So the one up here is going to be not quite straight, but slightly over. And this one's not going to be quite off to the left, but slightly up. And then these will sort of kind of slowly transition over. And this gives us this smooth shading effect. I've created another plane here to demonstrate this. This is shaded flat. And we can see this has the normals pointing off to the side, and then the ones on the top are just straight up. So essentially what's happening is the bottom edge of this plane here is being rendered like this face is. The top edge is being rendered like this top flat face, and the bottom edge is being rendered like this side here. But instead of rendering the whole side like this one is, it's then fading between this one, and then fading between this one and this one to give us that smooth transition. What this also means is that in this position, we now only have 1 vertex. We still have a potential of 3 vertexes, right? There's the one off this triangle, there's the one off this triangle, and there's the one off this triangle. Before, for this vertex, and this vertex, they all shared a position. But this vertex had a unique normal, whereas these 2 vertices both shared a normal. So we were able to collapse these 2 into one, and this one stayed unique, and so at this point here, we had 2 vertices. Now, this potential vertex, this potential, and this potential all share 1 position, and they all share 1 normal. So it is just now 1 vertex. If we were to export this into Unity, we would have 1, 2, 3, 4, 5, 6 vertices, whereas before we had 8. To show you something also interesting, I have created this example object here. It is a plane. It is cut into three sections, and the top is just pointing upwards. If we look at the side, we can see the top normal is pointing upwards. These side ones are pointing off to the right, and because it has smooth shading on, this one here, if we did flat shading, I'll just show you quickly. This would be two vertexes in the same position, and one will be up, one will be to the side. We're not doing that. We're doing smooth shading. So instead, we're averaging out those two angles into one. Across this top surface, it's going to do interpolation between what this normal looks like and this one. And then between this and this, it's going to have to interpolate again. But for this segment here, the normals are identical. There's nothing to interpolate between. And if we look at this, it's going to be very difficult with YouTube compression here. You can kind of see an edge. Let me switch to the stronger light. Maybe you can see it better now. Toggle on the edit mode and you can see the line is here, and there really is a line right there, a dark line. If we did flat shading, okay, well now the whole top is, shaded one way, the whole side is shaded one way, but with smooth shading it comes down to just this edge here, but it's not going to interpolate from this vertex to this vertex, right? Why would it go between these two? It's only going to go between this one and this one. And so we have this sort of bit of a dark, hard edge right here that we can see. All right, last thing about normals, but first I'm going to add a cube, switch to wireframe mode. You see it looks like this, and I'm going to export it over to Unity. Here in Unity, we have our cube, we drag it into the scene, and you can see it is triangulated. So even though it's not triangulated in Blender, it is triangulated in Unity, which I want to work in Unity with, in Blender with the same geometry that we will actually be using in Unity. So in Blender, I am going to pre-triangulate this cube, and I will export this one to Unity. And here in Unity, we see, yes, it looks exactly the same as it did before. So whether or not we triangulate first in Blender, the result in Unity is going to be the same, but I want to see, the exact geometry that we will be working with. So looking at this, we turn on edit mode and we take a look at the vertices. And what we notice right away is that this is not a single vertex. It has three different normals. We can see for the triangles, there is 4 triangles here. So we can call this triangle 0, triangle 1, triangle 2, triangle 3. And we'll call this position A. So triangle 0 has a vertex position A, normals off to the left. Triangle 1 has position A, normals pointing up. And triangles 2 and 3, they have positions A with normals pointing off to the right. We can see right away these two here and here are identical, so we can cancel out that one, point indice 3 at this existing vertex here, and what we have is 4 triangles but 3 vertices. Come to another one. This is 1, 2, 3, 4, 5 triangles, but again these two share the same vertice and these two share the same vertice. So again, 3 vertices. What we have here is we've got 4 positions on the top. We have 4 positions on the bottom. So we have 8 positions in total, but at every position there are 3 vertices. 8 times 3, 24. We take a look at the cube, we export it to Unity, inspect the mesh, and we see, yes, there are 24 vertices. Now you're thinking, okay, I know what we do next. We select the cube and we do shade smooth. Let's take a look at this. Okay. The normals are now pointing off at angles. It's been averaged between the 3 that were here before. So now we have the same 8 positions, but at each position, there is now only one normal that is shared between all of the vertices, or potential vertices that are at that position. So here we should have 8 vertices when we export to Unity. We come over to Unity, we look at our new smooth shaded cube, and we have 14 vertices. Not 8, not 24, but 14. Why is that? Well, position and normals are not the only 2 values here. We also have texture coordinates. Now, I haven't edited the UVs for this cube, but when it was created, Blender automatically created some UVs for it. So let's switch to the UV editor, and if we select everything for this cube, we can see our UV texture coordinates over here. And here we have, we can select, for example, this vertex here, and it will tell us that it is at position X equals 0.375 and Y equals 0.750. We have 2 positions here, plus 4 makes 6, 10, 12, 14. We have 14 texture coordinates. We have 8 different positions. We have 8 different normals. We have 14 different texture coordinates. The smallest number of vertices we can use to represent 8 pieces of data and 8 pieces of data and 14 pieces of data, we need 14 different containers. Let's slap a material on this. And I've got my UV grid. So let's take a look at where we think there might be a seam. Okay, we can move the position around and it treats it as if it's 1. That looks like this vertex here to me, the one at position 625 and y equals 5. And if we grab this over here in the UV editor and move it around, the UVs for these 1, 2, 3, 4, 5 different triangles, and we can see the 5 different triangles here, 1, 2, 3, 4, 5. As we move this around, all 5 of them are moving around. So right here there is one vertex. It is one position shared between all 5 triangles. It is one normal shared between all 5 triangles, and it is one texture coordinate shared between all 5 triangles. Let's look at this position over here that I've selected. And if we come over to our texture coordinates, it's going to be this one here. As I move this one around, we can see that the UVs are changing on 3 of the triangles. This triangle, and this triangle. As I move the texture coordinates around, it's being shown for those 3 different triangles. For this top triangle up here, it's not changing because it has a different texture coordinate. What we see is that for this position here, we're going to have 2 different vertices. So one of the vertices, both of the vertices will share a position value of this. Because we have smooth shading, both of the vertices will share a normal value pointing off something like that. These 3 triangles all have a vertex which has this texture coordinate, whereas this triangle up here, its vertex has a different texture coordinate, which I believe is this one over here. And as I already showed you on the right, we have our 14 different texture coordinates. Now if I select this face here, which is on the top, and I move this around, this point and this point, Blender, for convenience sake, is saying that this is a single texture coordinate and a single vertice, and it's shared between these different triangles. So if I move the vertex on one triangle, it's going to automatically move it for the other ones, just for convenience sake. What I can also do is I can right click on this triangle and hit split by selection. Now I can move this triangle separately. By doing this, by making this split, we've created 2 new vertices. This switch to vertex selection mode. This one and this one used to be the same. This one and this one used to be the same. So if I export this, now instead of having 14 vertices, we see it in Unity and we have 16 vertices. It's the exact same thing if we go over here and do right click, mark seams, and we can mark these ones as seams, and we can unwrap the whole thing, and now we have even more. This looks like an absolute mess, but you know, as we disconnected that other triangle, we created 2 more vertices, and now we're up to 18. Okay, hop back into Blender, we create our default cube, and we are going to triangulate it. And that's it. We're not going to do anything else. We're not going to change the UVs. We're not going to change the shading. We'll just leave it just like this and export it to Unity. Here we have our cube. It's in the scene. It's beautiful. Let's select the game object, and we're going to add a new component, and I'm going to call it vert mover. We can delete these comments. We're not going to need the update function. Actually, let's go back to Unity. Let's put a material on this. It might make it a bit easier to see. I put my UV grid material back on just to give us a reference of, you know, are we looking at the front, the back, the side, whatever, right? Here's our cube, looking snazzy, and we have the vert mover script on it. Now, first thing we need to do is access the mesh. So you can see here quite easily, there's the mesh filter component that's got the mesh on it. So get component mesh filter dot mesh, and we'll say mesh cube equals get component mesh filter dot mesh. Now we can access the vertices by doing cube dot vertices, and this returns, we hover over it, returns an array of vector 3s, which makes sense. Vector 3 array verts equals cube dot vertices. And let's say we want to change vertex number 4, whatever that is. Verts 4 equals new vector 3, and for the values we'll have verts 4.x. Let's say we want to just move it up, so we'll increase the y value by 0.01. Now we'll take the cube vertices, and we've edited our array. We're going to reassign this modified array to the cube. Back in Unity, we press play, and then we get an error saying we can't actually access the vertices because the mesh is not read-writable. So we find the mesh, and here we go, and we set read-write enabled apply. Good. Now we hit play, and we see over here, this has moved. So this must be vert 4. Now, because we don't have backface rendering enabled, we can't see inside of it, but there's, of course, the 3 sides of the cube, right? We call this left, right, and bottom. And here there are 5 triangles. There's 2 on the bottom, which share this position. There's 1 on the right, which shares this position. There's 2 on the left, which shares this position. So apparently, vertice number 4 is a single vertice shared by these 2 triangles. Now, what would be great is if we could actually identify this vertice in Blender, because just typing in 4 and hoping, if I want to move this vertice, what number do I move? In Blender, I can go to Edit, Preferences, Interface, and make sure Developer Extras are turned on. With Developer Extras turned on, let me hide the normals here. With Developer Extras turned on, I can select Indices, and it depends on what mode you're in, right? So I'm in Edge mode now. If I do Face mode, this says it's Face 11, and that's Face 5. If I do Vertex, that's Face 3. Vertex 3, this is Vertex 1, and it's pretty hard to see on the screen here, but if you can read it, that's great. If not, sorry. In Unity, we moved this one down here. This is like on the side where it says 0.4 and it's kind of purplish. And so let's find that position in Blender, and I come down here and I click on this vert and it says 2. In Unity, I targeted 4, right? This was 4. This is the same. This is definitely the same looking at the model, but Blender calls this 2. All right, what's the one right above it called? Blender calls this one number 3. We change our code to target vert 3. We come into Unity, and this was supposed to be vert 3 according to Blender, but it's not. Actually, it looks like this one is vert 3 over here. Unity has a feature called Optimize Mesh, and if we do the tooltips, it says reorder vertices and or polygons for better GPU performance. Let's turn this off. Let's set this to nothing, apply, and we're still in code trying to go for vert number 3. According to Blender, this one right here is vert number 3. We hit play. Interesting. It has moved this from this position, but it turns out that, as we already know, because we can look at the normals here, as we already know, there are 3 vertices here. So Blender tells us 3. It doesn't tell us, is it, for this triangle, these 2 triangles. So it turns out vert 3 is actually the vertice that is shared by these 2 triangles here. So let's say I want to move the one for this triangle on the top. How do I find out what number that is if Blender just tells me 3? To find the vert, we have to first find the triangle. So I switch to face selection mode and I click on this top face and I see this is triangle number 11. Over here we have 7, that's 0, that's 6. We want to get the vertice from this triangle, and this is triangle 11. So first, in the code, let's get triangle 11. Cube.triangles returns an array of integers. It is the list of indices, essentially. If we have tries, the first triangle is going to be at 0, 1, and 2. So what we can also do is we can define, let's say, a try index, and we'll set this now to be, we'll set it to be 11 because that's what we're looking for. And what we'll do is we'll go try index times 3 plus 0. And then we'll do the same plus 1 plus 2. I hope this makes sense. Obviously, you don't actually need to do plus 0. I'm just doing it to demonstrate we're getting vert 0, vert 1, vert 2. You could, of course, do, just like this. But if we want to get triangle 0, then 0 times 3 is going to be 0. So it'll be 0, 0 plus 1, 0 plus 2. So for triangle 0, it's going to be 0, 1, 2. For triangle 1, 1 times 3 is 3, and then plus 1 and plus 2. So for triangle index 1, it's going to be 3, 4, 5. Those will be the indices of the verts. And let's grab vert 0, and we will set that to be moved over slightly. We'll move these all up. And I noticed before what was happening is we set to move the Y and it was moving left, and that was because I forgot to apply the transform in Blender. So actually, even though in global coordinates Y is up, in local Y was to the left, because Blender has different coordinate systems. So I applied the transform and brought the model back in, so now Y will actually be up. And reassign our array to the cube, save, and look at it in Unity. We press play and we can see that yes, these 3 vertices have all moved up. Now, 2 of these vertices are shared with this triangle here, which is triangle 5, this one that only exists on triangle 5 hasn't moved. So we have moved up these 3 vertices. And let's also just debug print the index of these. We'll say try index has verts, vert 0, 1, and 2. So try 11 has verts 15, 17, and 23. In Blender, it looks like it has verts 3, 7, and 1. But as we know, this is not, the exact position. I have changed the texture on my cube in Blender. Instead of just the normal UV grid, I've got this UV grid with these numbers painted onto it. And I have marked seams. You can see the seams on the top, cutting out the top face completely, as well as seams down the sides. With the top face here, I've lined it up to be with this over the number 0. With all the other faces, I've just shrunk them down and put them in this nice looking purple area over here. So it's just purple. We're going to focus on this top face. We want to move the UVs for this where it currently says 0. We want it to say something else. Coordinate system, the bottom is 0, 0. This point here is going to be X is still at 0, but Y is now all the way up at 1. This point over here, we've moved over 0.2. For these values, Y is 1 here, so we go down minus 0.1. So this is 1, 0.9, 0.8, 0.7. If we wanted to shift this over to, let's say cover 1, we would shift over all the vertices by 0.1, 0.2. We can actually do this in the editor here in Blender by just doing, plus. So if we do plus 0.6, that's moving it all the way over, and you even have the number right here, 0.6. We're starting off in the corner, and then with code, we want to select these, the UVs for the top triangles, and move them over by 0.6. So the 0 becomes a 3. And before we leave out of Blender, let's go to face select mode and look at the top triangles are 5 and 11. So here we are starting off. First, we're defining our triangle indices. So these are the triangles we want, which we saw were 5 and 11. Then we start off, we get the mesh filter component, get the mesh, and we save that. Then we get the mesh triangles. This is the indices, right? They're not triangles, they're indices, from which the triangles are derived. Then we get all of the UVs, and the naming here is a little bit funny. So if we do, mesh.uv7, we are getting the UVs of the 7th vertex. The 7th vertex, we get the UVs. If we do mesh.vertices7, we are getting the position of the 7th vertex. It might seem like dot vertices would give you the vertex. It doesn't. It just gives you the position. So the naming is such that you access vertices to get position and you access UVs to get the UVs, but it's still, it's still the 7th vertex. We save all of our the UV values of all of our vertices into UVs. Next, we're going to save all of the vert indices into a list, and then we loop through our triangles. So triangle index, first we loop through 5, then we loop through 11. This might correspond to, let's say this here is vertex 7. Triangle 5 tells us to access indice 15, which then tells us indice 15 points to vertex 7, and then we save vertex 7 in our vert indices, and then, whatever the next ones are. And then we go through 11 and we get 33, 34, 35. And we save all these in the vert indices. Then we loop through all the vert indices. And we say, okay, we have the UV values of all of our vectors. This here is vert 7, we're assuming, right? For the vert 7, we want to set the UV value to be equal to a new vector 2, where the X component of the UV value is the same as it was before, plus 0.6. The Y component is exactly the same as it was before. And we loop through all of those verts, and we assign the UV values back to the UV property of the mesh. Let's go over to Unity and press play. And it didn't work. So why is that? Well, it's pretty obvious. We took this vertex, moved it, the UVs 0.6 to the left, then here, move 0.6 to the left, then here, move 0.6 to the left. That's this triangle done. We go to the next triangle. We take this one, move it 0.6 to the left. But we already moved it before for this triangle. We need to limit our triangles, or limit the verts, so we only move them once. I add a new line of code where we create a new list called distinct vert indices, and that's vert indices dot distinct to list. So distinct just make sure so we don't have any duplicates in there. We go to Unity, we press play, we wait for Unity, boom, 3. Perfect. We're now shifting UVs. We're identifying the triangles, grabbing the verts from those triangles, and moving the UV values around programmatically. And just for a bit of fun, let's make it so we can set the number. So we have a public integer called number, default to 0, and then the X transfer amount is going to be 0.2 because each number is 0.2 wide times the number modulus 5. So if it's 3, then the remainder of 3 divided by 5 is 3, so we'll move over 0.2 3 times. Y transfer amount, basically if the number is less than 5, it's in the top row, so it's 0, otherwise it's in the second row, so it's 0.3. And you got to remember, because Y is 1 at the top and we're coming down a row, we have to subtract by the Y transfer amount. And we can see all of our cubes. This one has the number set to 5, this one has it set to 3, and we're doing different combinations of numbers. How fun. You don't always want to use this technique of moving UVs around in code. In fact, you only really want to use it if you want to generate like a huge variety of things. In the beginning, I had my post-it notes, and there's 1,600 varieties of post-it notes, okay? If you're doing like a truck and you've got 2 teams and you want to use the same model truck, and you only want to have one texture, you can just set different UV maps. So here I am in Blender, and this is my current UV map with 0 on the top. Let me create a new map and switch to that one. And I go to UV editing and I select where it says 0, and I'll move that, and it says now, actually let's just change the size as well. So we'll, stretch this out a little bit like this, and we'll stretch this one out, boom. And now we've got the padlock. Here's the first map, it says 0, the second one is a padlock. When we look at our mesh in Unity, we see we now have UV0 and UV1. So by default, we're using UV0. An easy way in the interface is you can, on the object, check swap UVs, and that will swap UV0 and UV1. So we do that, we hit apply, boom, we're at the padlock. That's all we have to do to change them up. But if you want to do it programmatically, I'll just set this back. You have these functions, set UVs, where you specify the channel, or get UVs and we specify the channel. It's not something you want to do with complicated objects. It's really when you want hundreds and thousands of different UV combinations. You can have 8 channels of UVs. So if you don't need more than 8, then just do it this way. Final thing that might catch you up, and the reason I told you about different UV maps is because if you're doing a truck, you shouldn't really be doing this because things can get complicated very quickly, but we're going to do it to a truck anyways. So here I got the truck. If we go into edit mode, you'll notice that I've marked seams around the hood, and I've cut out this area here, and we've unwrapped everything. And right now we have 4 triangles, these 4 right here, 7250, blah, blah, blah. And currently they are on this green part that says 0.7. If we go to UV editing, select these 4 triangles here. I want to change it up a little bit, so I'm thinking for the X coordinate, let's just subtract by 0.6. 0.7 becomes a red 0.1. We bring the model into Unity, we select it, we go to the settings, we say optimize mesh nothing, read write yes, we hit apply. We go to our script, we modify the script to have those 4 triangles we just saw in Blender, and the change we want to do is we want to subtract by 0.6. Back in Unity, we press play, and hopefully this hood will change to a red 0.1. And it does. Perfect. So this is great. We've just taken a complicated model in Blender, we've identified the triangles we want, and then moved them to a set position, for our UVs. So we're able to do kind of anything we want. Here is where we now have a problem, a potential problem. And this is if we have multiple materials, because materials are not saved maybe in the way that you would think. So let me add a new material here, and this will just be, a dark color. In this, I'm going to press L to select loose objects, and I'm going to select these wheels. So select all these wheels, and I will assign this material. Oh, I was also selecting my faces up here. I don't want those. I just want the wheels. So assign. Great. We now have 2 materials, the UV grid and the wheels. I do want to assign the wheel material to some of these triangles. So I'm going to pick a couple of triangles around the hood here. Let's say like these ones, and that's good. We'll assign the wheel material to this. I'm going to take my truck and export it to Unity. Just want to note that we haven't changed the identifying numbers of anything, right? These 4 triangles, if you remember, these are still the same 4 triangles they were before, 7250. We look at our truck, we see, yes, the tires are black now, there's black around here. We inspect the object a bit, and now we see there are 2 submeshes. Let's just run this first, actually. The script's the same, we haven't changed that. Find these triangles, move the UVs slightly. All right, Now, this has completely messed up because what's happened is the triangle indices in Blender have stayed the same. The way we're defining materials here, you know, I can take my UV material and if I point it at these tires, it's going to change all of those. Actually, let's just do that. Let's set the UV material on here. So now the wheel one, if I put this on the truck, it does the truck. And if I do the wheel, it does the wheels plus this little bit of the hood that we set. And the reason it knows to associate those is because those are defined as submeshes. And the submeshes are defined as a order of indices. So the first submesh 0, is going to be indices between 0 and 39,465, and then the next one will be between that number following the next 10,000 something indices. The order of things have gotten all jumbled up. Okay, this vertex hasn't changed. We changed the material for this triangle here. We didn't change the UV coordinates. We didn't change the position of the vertex. We didn't change the normals. So it's still the same as before. But now as we're moving texture coordinates around, we're running into problems because they have different materials, because they're considered different submeshes, because the order that things came in the indices has now been moved. So we can group all of the truck vertex indices together and all of the wheel indices together. This is a situation where you really shouldn't be doing any of this to begin with. Use UV maps, blah, 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 blah. But I will show you a simple workaround if you are in this kind of situation. So this triangle here is 7251. This is 7255. We can see these are all close together. Here's what I'm going to do. I'm going to select everything. I'm going to go mesh, sort elements, sort by material. And down here we make sure we're sorting material by faces. This is changing the order of the triangles essentially. So this one is now 7249. This one is 13,000 something. We go to the wheel. This is 15,000. So this triangle is now sorted in the indice list closer to this one than it is to this one. This is not a technical explanation. There are other ways to target submeshes, but I think at this, you can figure this out if you want to do advanced techniques on your own. So I'm going to export this with my triangles reordered. Press play, and it doesn't work. Oh, obviously because we've we resorted the faces, the triangles, so these now all have different indices. So this is 7249 all the way up to 7252. So we go back to the code and we'll say 7249. And this is 752 now, I believe. Is this right? Yes. Okay. Save this. And now it switches over to 0.1. Starts at 0.7. Press play. Moves to 0.1. Boom. This is a hack, right? Reordering the faces to make it not look, it worked great for post-it notes, okay, and you know how to do that now. So thank you for watching this very, very long video, and I hope you learned something. Also buy my game, please. Thank you.